Okay, so let's see how you did here. The first one is y equals, so that's already in the form for graphing. So how are we going to graph that one? Where are we going to start? That's the number that's added or subtracted. In this case, it's minus 2. So from the origin, all graphs start at the origin, and this one is going to move down 2. So it's going to go through the y-axis at negative 2 there. So that's our starting point of this graph. And then the number that multiplies the x is our slope. So the top number is a rise, and the bottom number is a run. So from this point here, we're going to rise 3 and run 2. So there's the second point of this graph. And the line goes through those points. Now the second one here, move it up so you have a little room to work with it, is not in y equals form. So we're going to have to move it around a little bit. So we have to get y by itself. I have to get rid of the 3x, and I have to get rid of the negative 1, and I have to get rid of the 4. Now it doesn't matter here which one I get rid of first, whether I get rid of the 3x first or the negative 1 first. So I'm going to do this. I'm going to add 1 to get rid of the negative 1. So this is 3x plus 4y, and 7 plus 1 is 8. Now I can come back and get rid of the 3x. It's a positive 3x, so I'm going to subtract 3x. So I have 4y equals 8 minus 3x. And finally, I'm going to divide by 4. Now remember, when we added or subtracted, we only have to add or subtract to one piece on each side. When we multiply or divide, we have to do it to every piece on both sides. So here we divide by 4, so that leaves us with y, cancels out the 4. Here we have to do 8 divided by 4 is 2. Negative 3x divided by 4 is negative 3/4 x. So where's this one going to start? Positive 2. So from the origin, we go up 2. Right there is where we're going to start. Now our slope is a negative 3/4. Remember, the negative goes with the rise. The run is always positive. So from this point, we're going to go down 3 over 4, run 4. The last one down here, a line with a slope of 1/2 going through the point 4, 5. I put this one on here. It's not a terribly difficult one once you see it, but there's something I wanted to point out. So the point 4, 5, we have to go over first. When we do the points, it's x and then y, horizontal then vertical. So it's over 1, 2, 3, 4, up 1, 2, 3, 4, 5. There's the point that we're talking about. From there, we're going to do our slope, which is 1/2. Now the difference here is with the slope, the first thing is the rise, the up and down. And the second thing, the 2, is the side to side. So that's just backwards from plotting points. When you're plotting a point, you go side to side first, and then you go up and down. When you're doing a slope, you go up or down first, and then you go over to the side. So be careful. That's something that really confuses a lot of students. So now from that point, we have a slope of 1/2. So from here, we're going to go what? Up 1, over 2, just like we would if we were starting from a y-intercept. So there's that graph. What's that? This one here? Yep, so we have to start at the 4 or 5 here. So we went over 4, up 5 to get to that point. Slope is 1/2. So starting at that point, we rise 1 and run 2. There's our second point. So our line goes through those 2 points. So we just continue it on. Just like here, we started at negative 2, so we went from here down to 2. We did the slope from there. Well, the difference is our point isn't on the y-axis. It's just out in space, but we can still start from there and do our slope. So I want to make sure we get some practice changing these from whatever form they're in into that y equals form. So we might have x minus 2y equals 6. I would try to rearrange that one and put it into graphing form. And also 3y plus 2 equals 2x minus 7. Try to get those two in that y equals form and graph them quick. So the first one here, we have to get y by itself. Y has been multiplied by -2, and then x has been added to it. So we're going to subtract x. So -2y equals 6 minus x. Divide by the -2. So y equals -3 plus 1/2 x. Or you could have put that as x over 2, but remember we talked about this in the last couple of weeks. X over 2 is 1/2 times x. Having it in this form, it's easier to see the slope. So we're going to start at -3. And from there we're going to go up 1 over 2. Here's your line. Down here, y has been multiplied by 3 and 2 has been added to it. So we will subtract 2. So 3y equals 2x minus 9. Then we'll divide by 3. Y equals 2x divided by 3. Oops, that line goes fast. 2x divided by 3 is 2/3 x. -9 divided by 3 is -3. So from there we start at -3 again, right there, and we go up to over 3. How many got both of those right? Any questions on those? Hannah, is that kind of all the types you were struggling with? Or? Okay. So if we have something like this, remember, in order to graph it, we have to have it in this form where it's y equals and everything else is on the other side. So what we have to do here is we have to solve this so that y here is all by itself. So we're going to have to get rid of the 3 and we have to get rid of the 6x. This is just like if we had an equation like 5 plus 2x equals 13, like that. What would we do to solve this equation? We would subtract 5. And then we would divide by the 2. X equals 4. This is the exact same process over here. We have to subtract what's away from our variable. The 6x we're treating as though it's just part of the x is part of the number. That's 6x. It's all one number. So we're trying to get y here by itself. So we have to get rid of the 3 and the 6x. Now if we're looking at how this was built, the y had to be multiplied by 3 before the 6x could be added to it. When we take it apart, we got to take it off the last piece first. We got to go in backwards order. So we're going to subtract the 6x because it was added to it. Make that go away. We'll subtract 6x on the other side. Now all that's left over here is the 3y. Everything else was, the 6x was taken away. On the other side here, 9 minus 6x is just 9 minus 6x. We can't combine it at all. Then we divide by 3 to get rid of the 3, leave y by itself. When we divide, we have to divide every piece on each side of the equation. So we divided the 3y, now we got to divide the 9. Divided by 3 is 3. And negative 6x divided by 3 is a negative 2x. So if you want to graph that, the number that's away from the x is where we start. So the 3 here is all by itself. It's not with the x. It's a positive 3, so that tells us we start at positive 3 right here. The number that multiplies the x is our slope. We have to make sure it's a fraction. So since it's just negative 2, we make it negative 2 over 1 to be a fraction. So now from that starting point, that tells us we rise a negative 2. So we go down 2 and run 1. Let's talk a bit about slopes. You know, slope is what we saw up here. It's that number that multiplies x. And that's what tells us from our starting point how far to go down or up and then over. Over, of course, we always go left to right. Positive goes up, negative goes down. Well, if I give you a graph, how would I find the slope of that line? Well, I just have to pick 2 points on that graph that go through coordinates, or what we call lattice points. Well, these are pretty easy. I gave them to you right there. Those are lattice points. See where it goes through the axes. And then I have to make a ramp that goes up and over to connect those points. So from this point, I have to go straight up. From this point, I have to go straight over until they hit right here. How many units did this go up? 1, 2, 3. So it has a rise of 3. How many units does this go over? 4. Perfect. So it has a run of 4. So rise over 1 is 3 over 4. That's my slope. Always double check the line. Does that look like a positive slope? Yeah, going from left to right, it does go up as we go left to right. So that is a positive slope. So I have a line that goes through these 2 points. We find those 2 points, we do the same thing. We draw in that triangle that connects those 2 points. What's our rise here? It's 2 units, but it's actually going down. It's a negative 2. Because going from here to here, we're going down first. Then we're going over. What's our run? 3. Perfect. So that slope is a negative 2/3.
You just put the negative sign of
the negative always goes with the run. Yes. Or not the run, the rise. Positive or negative always goes with the rise. The run is always positive. I want you guys in your notes find the slopes of those 2 lines for me quick. Okay, so let's look at this one here first. It goes from here to here. What's my rise? Well, first of all, what'd you get for a slope? -2. over 5, right? Negative 2/5. That's perfect. That's our slope. We have 2 units here, but it goes down, so it's negative. And 5 units there. For this one, from there to there, what's our rise? 3 run of 2, so 3 over 2 slope. Perfect. Any questions on that? So then, looking at these points here, if I didn't have them drawn on the graph, is there a way I could find that slope? Well, this coordinate here is 2, 4. This coordinate here is 4, 7. If I look at my slope triangle over here, the rise is created by what coordinates? The x's or the y's? Well, what coordinate goes up and down? The y's. So if I'm looking at my slope, there's a rise over a run. I could have found my rise by subtracting my y coordinates. The run then would be the x coordinates, the side to side. I could have found my run by subtracting my x coordinates. 7 minus 4 gives me my rise of 3. 4 minus 2 gives me my run of 2. A 3 over 2 slope. The formula for that slope, the symbol we use for slope is usually the letter M. If I have the points x1, y1, and x2, y2, that's just saying x coordinate of the first point, y coordinate of the first point, x coordinate of the second point, y coordinate of the second point. Our slope is equal to y2 minus y1, that's the rise, over the run is x2 minus x1. So if you're just given 2 points, like that, to find the slope, if I call this point 1 and this point 2, for some reason that's always easier for me to label them 1 and 2. It's y2, so that's point 2, the y coordinate, which is negative 1, minus y1, which is point 1, the y coordinate, which is 3. So that's on top. On bottom, it's x2, so that's point 2, x coordinate, which is 13, minus x1, so point 1, x coordinate is 5. Negative 1 minus 3 is negative 4. 13 minus 5 is 8. Negative 4 over 8 reduces to a negative 1/2. So that's a negative 1/2 slope. Yep, the y's are always the rise on top. Yep, it's always this formula right here. So in your notes, find the slope of the line between those 2 points. So our slope, M, equals what's going to go first here on top? 0 minus 5. Good. On bottom, what's going to go first? 7 minus negative 3, right? So now we do have to deal with some negatives. 0 minus 5 is negative 5. What's 7 minus a negative 3? That's 7 plus a positive 3, which is 10. Negative 5 over 10 is negative 1/2. Good. What if I gave you that equation? I asked you for the slope. What's the slope? Two-thirds, yeah. The number that multiplies the x is the slope. So that's just 2/3. So for this one, the slope is careful. The number that multiplies the x. That's the negative 3. If I give you this one and ask for the slope, it's not as simple, is it? We have to do a little bit of work here. We have to get y by itself. So I'm going to subtract the 2x. That's gone. This is negative y. 3 minus 2x is just 3 minus 2x. And then think of that as being a negative 1 times y, so we're going to divide by a negative 1. So that's y equals 3 divided by negative 1 is negative 3. Negative 2x divided by negative 1 is a positive 2x. So my slope then is 2. You could think of it as 2 over 1 is probably an easier way to think of it, but 2 is just the slope. So if I look at this graph here, finding the equation for it, take a look and see if we can figure that out. Find the equation. Now remember, y equals something times x and plus or minus something else. This is the slope times x plus or minus the y-intercept. This piece here is probably the easiest to find. If I start at the origin, where do I have to go to where the graph crosses the line? It's up 3. Yeah, it's up 3. So that's a positive 3 because it's 3 up from the origin where it crosses that y-axis. Now I need the slope here. I've got this point and I've got this point. What's my rise here? Negative 3. We're going down 3. And my run? 4. So slope is negative 3/4. So the equation there is just y equals negative 3/4 x plus 3. That's it. So see if we can find the equation for that line. Well, I'm going to start out with, this is at -2. Perfect. So this is going to be -2 because it goes to the or the y-axis 2 units down from the origin, from the center. What's my slope now? Up 2 over 3. So 2/3. So y equals 2/3 x minus 2 is my equation. Try to find the equation of that line. So y equals something times x plus or minus something else. We'll do this piece over here first. What's that going to be? From the origin, we go up 1, 2, 3 is where that line goes through, so it's +3. For my slope, we rise 2, we run 4. So you're right, 4, not 5. So now it's 2 over 4. So the equation y equals 2 over 4 can be reduced to 1 over 2, 1/2, x plus 3. If you're left with this y equals 2/4 x plus 3, that would be fine. Any questions? Okay, for our second part of class today, we're going to look more at these formulas that we've been working with and a couple of different applications. And we're going to be looking at strictly machining-based formulas, or mostly machining-based formulas today. Like the formula for measuring threads on a bolt or a threaded rod or whatever. And the formula is going to look like this. M is equal to D minus 1.5155P plus 3W.
Something you want us to write down.
Now this is just adjusting a formula is all it is. It's literal equations or rearranging formulas again. Any formulas you need to work with will be given to you in the assignment. But anyways, let's say I want to solve this for W. So I want to get W here by itself. Well, W has been multiplied by 3. D has been added to it, and the 1.5155P has been subtracted from it. So I have to take this back apart. I have to reverse those steps. So I can either get rid of the D or the negative 1.5155P first. It doesn't matter. I'm going to go ahead and subtract D. So that's gone. What's M minus D over here? Exactly that, M minus D. Good. Now this is still a negative 1.5155P plus 3W. Now that 1.5155P has been subtracted, so we have to add it. So that's gone. We have M minus D plus 1.5155P equals 3W. The last thing we have to do is divide by 3. m minus d plus 1.5155p over 3 equals w. Now, if there were numbers in front of each of those letters, we'd maybe try to divide each of them by 3 and make them separate. But since there aren't, we can leave it like that. Or we could have done it as m over 3 minus d over 3 plus 0.50527p. Notice I did divide the 1.5155p divided by 3. Either one of those is just fine. These look familiar? Yeah? Sort of? Well, we might have one that's a little bit more fun. Like this. A equals r minus the square root of r squared minus 0.25 w squared. We're asked to solve this for w. So we've got to get w here by itself. There's a lot of crap to get rid of here. Since we've got the square root, the w is inside that square root. The first thing we've got to do is get the square root by itself. So we've got to subtract r. So we have a minus r equals, that's a negative square root of r squared minus 0.25 w squared. Now I have to get rid of that negative. So it's a negative times that. I can either divide by -1 or I can multiply by -1. It's probably easier to think of multiplying by -1. So if I multiply that by -1, that becomes a negative a plus r. -1 times a is a negative a. -1 times negative r is a positive r. Then this is the square root of r squared minus 0.25 w squared. Now that we got that square root all by itself, we're going to get rid of it by squaring.
Why did you do that? -1?
Because it was a negative here. I get rid of that minus in front of the square root. So I'm going to square that. That'll cancel out the square root, but I have to square this side as well. Well, rather than actually multiplying that out, I am just going to leave it as a negative a plus r squared. Over here, the squared and the square root cancel out. So this is r squared minus 0.25 w squared. Now, I need to get w by itself yet. I've got to get rid of the r squared. This is minus a plus r squared minus r squared. Equals, this is a negative 0.25 w squared. What are we going to do next? Careful, we're at one step first. Perfect. Got to get rid of the negative 0.25. We're going to divide by negative 0.25. So this is a negative a plus r squared minus r squared over negative 0.25 equals w squared. Now we will square root. That's the square root of negative a plus r squared minus r squared over negative 0.25 equals w. Not so bad. That one's kind of ugly, I'll admit that. I won't do that to you on a test or quiz.
Well, if you do, you can keep it short. Move the negative a plus r squared out.
No, you don't have.
That second r squared.
No,
that
you.
would go away.
Yeah, it would go away. You're right. You could square it out. You'd have a squared minus 2ar plus r squared, and that would cancel out the r squared. But you could leave it like this. That would be fine. If I ask you to solve this for B, the first thing you see is that there is a B on both sides of the equation. These are equal signs. There's a B on both sides. And when the variable we're solving, if we were solving for x and that was all numbers other than the x, if there was an x on each side, we'd have to get rid of one of them first, wouldn't we? We would get rid of the smaller one first, but we don't know which one's smaller. We don't know what A and P are. So I'm just going to go ahead and get rid of this one here. I'm going to subtract PB. That's gone. Subtracting PB over here. So on the right side, all that's left is the J because I subtracted the PB. Over here, I'm going to subtract the PB from the AB. Now, if this were like 9x minus 3x, I would get what? 6x. 9 minus 3 right here. Gives me the 6. Well, here I've got AB minus PB. That's A minus PB. Does that make sense? I've got the plus CM. That all equals blue. Now I've got to try to get B by itself. Subtract the CM. So I have A minus P, B equals J minus CM. And finally, I just have to divide by the A minus P. So B equals J minus CM over A minus P. What do you think? Not terrible?
How come B goes on its own after you subtract those two?
Well, I divided them, so that divides
Oh,
out.
no, back up.
Okay, because if this were kind of like I did here, if this were 9x minus 3x, I would do the 9 minus 3 gives me 6. Well, the same here. It's A, B minus PB. A minus P gives me this, and that's times B.
So it would be like 9 minus 3 in parentheses.
Yeah. This would become, 9 minus 3 times x, like that. Yeah, good point, Adam. So here's a similar thing. I'm going to solve this for x. And the x appears twice, but they're both on the same side of the equation. So it's the same concept. mx plus bx will be m plus b times x. Still have the plus a, and still equals c. So that's the same thing. That's if we had 3x plus 5x. It's going to be 3 plus 5 in front of the x, or 8x. So now we will subtract a. M plus b times x equals c minus a. And then we'll divide by the m plus b. So x equals c minus a over m plus b. What do you think? I have a packet I'm going to give you, and I want to make sure you guys get time to do quite a bit in this packet. It involves this stuff here, and it also involves stuff we were working on a couple weeks ago where I give you a formula like P equals MT minus S, and I ask you to evaluate for M equals 8, T equals 3, and S equals 5. So all you're doing is putting in those values and doing order of operations. So M is 8, T is 3, so that's 8 times 3, minus S is 5. And do the order of operations. You multiply first, 24 minus 5, then you subtract, you get 19. So evaluating that is 19 for those values. But the reason I want you to get a good share of this packet done is because these are all machining formulas, and these are formulas you may actually work with. So in this packet, there are going to be problems starting, and I'll hand you the packet in just a little bit. on page 221 through 224. One through 55, again, probably just the odds. And page 242 through 245. That's 1 through 57. Again, the odds. And I think I'm going to hold off on the spur gears because we'll probably talk about that next semester. But the big one is this one here. Make sure you get that one done. Then this next section here is a good one to start. We'll look at that one more later as well if we need to. And I will pass that packet out right now.